Hello everyone, I am Tushar and welcome to the demonstration of our latest project, which is a secure chat application designed to meet the demands of today's digital landscape. I have to say, until I started building this app, I didn't give much importance to what goes on in the backend with my message when I click on send. The complexities of encryption and cryptography are fascinating to say the least. With the exponential growth of online communication, the need for robust security measures to safeguard user privacy and data integrity has never been greater. From personal conversations to sensitive business discussions, users deserve a chat platform they can trust. Our project aims to address this need by complying with the three basic principles of confidentiality, integrity, and user authentication, while also innovating something new and resilient. Over the next few minutes, we will delve deeper into how we have achieved these objectives and the innovative design choices that underpin our secure chat application. So let's dive right in. The app is built on React.js with a Firebase database. It is a client-side application and runs on the browser while interacting with Google Firebase for exchange of data. This means most of the hard work is done on Firebase, which is auto-scaling in nature and doesn't need any developer maintenance that a general server-based SQL database would need, hence making it a resilient choice. Using Firebase also meant we can use Google Cloud Functions to interact with the database and execute any admin level commands we want in the database, providing us with a great deal of control. To implement CI/CD, we hosted our app on Versal.com, which is a hosting service for several apps, including JS applications, which can be directly linked to a GitHub repository for auto deployment and rollback. Versal also provides us with a CDN and edge network that helps us deliver our application globally with low latency and bandwidth consumption. Versal also has the ability to auto scale as the traffic increases. Authentication mechanisms serve as the first line of defense in ensuring that only authorized users gain access to our chat system. We have chosen Firebase authentication for its convenience, flexibility, and other security features. With support for various login protocols, including email and password authentication, Firebase ensures that user accounts are protected against unauthorized access. End-to-end encryption is essential for maintaining message confidentiality, ensuring that only intended recipients can decrypt and read message. That's why we have implemented RSA asymmetric encryption, a reliable and widely used encryption algorithm known for its robustness and security. It immediately solved the problem of integrity and confidentiality for us using encryption and digital signatures. We spent a lot of time brainstorming on how to work out the key management for an asymmetric web application. Because it is a web application, it makes sense for the user to be able to use it from different devices and networks. This proved to be a problem because we had to store a private key somewhere on the local device when a public private key pair was generated, which was during user registration. We did end up solving this problem, which you will see in the technical demonstration later. We didn't stop there. To add an extra layer of security, we have integrated steganography into our chat application. By hiding messages within images in plain sight, steganography allows us to conceal sensitive information from prying eyes, further enhancing the security of our platforms. For this, we used a widely used steganography library. Now let's dive into the technical aspects of our secure chat application. First, let's walk through the user authentication process. Users can sign up, verify their email, and log into the system seamlessly using Firebase authentication. This ensures that only authorized users can access the chat platform. We'll do this right now. I'll open two incognito browsers and do the same process on both of them. We're using two browsers so that we can simulate two different devices and communicate between each other. I have verified both emails, and as you can see now I can log into the app from both the browsers as different users. Now let's add two of the users to each other's accounts and do a little communication test. When a user sends a message, it's encrypted using the recipient's public key along with a digital signature being created using the message digest and sender's private key. At the recipient's end, the message is decrypted using their private key, while the digital signature is verified using sender's public key, ensuring end-to-end encryption, message confidentiality, and integrity. Now let's showcase the steganography feature. By encoding and decoding hidden messages within images, users can communicate securely without raising suspicion. This adds an extra layer of security to our chat application. While the images that are being sent are not encrypted, a message can be hidden in them in plain sight without anyone knowing if the image contains a message or not. So as you can see, I encoded an image with a message and then I could decode the same image seeing the same message. Now while any user can encrypt and decrypt any image with any message, the highlight is that the message is hidden inside the image in plain sight. The image looks same as it was before encoding and after encoding, so no one can tell if an image contains a message or not, which provides users with an extra layer of security in case anyone is watching over their messages. Moving on to key management, we'll walk through the process of key generation, storage in Firebase, and resetting the keys. This ensures that users' encryption keys are securely managed and can be reset if necessary. A while ago, we discussed the problem of logging into different devices while keeping an end-to-end encryption. So we solved this by letting user reveal its private key on the app. Using this private key, a user can log in into a new device by using the old device's private key, and without it, a user cannot log in into a new device. Let's try this by opening a third incognito browser and trying to log in with a previous account credentials. As you can see, we have been prompted for a private key and will input the old device's private key to log in here. As soon as we do that, the private key is stored in that local browser storage and we are able to log in. Now that the private key is stored in that local browser storage, we'll be able to decrypt the messages that are already there on the server. A new problem arises here. What if the user's device is compromised? So we handle that by providing an option to reset the keys. If a user thinks that its old keys are compromised, a user can reset their keys. This would mean that they can't see their previous messages, but it would also mean that any new messages sent would be secured in case the old keys were compromised. Additionally, we have implemented secure persistent storage and self-destructing message feature. Messages are encrypted before being stored in Firebase and can be stored forever. providing secured persistent storage at server. Self-destructing messages are automatically deleted after a period of 5 minutes using Google Cloud functions with no trace of those messages. This provides users with an additional layer of data security and privacy. To not exceed our cloud free tier limit, currently the Google Cloud function runs every 1 minute to check for messages to be deleted. So it takes anywhere between 5 to 6 minutes for a disappearing message to get deleted. While this message gets automatically deleted, let's talk about some other message features. To prevent X-axis attacks, input sanitization is applied to user inputs, ensuring that chat application remains secure against malicious scripts. So if I enter a script tag in the message input, it won't be sent. Now, finally, let's see the integration with OpenAI's GPT for advanced chatbot functionalities. Users can receive intelligent responses and suggestions, enhancing their overall chat experience. Now, let's talk about the resilience of our chat application and our plans for future enhancements. To ensure data backup and restoration in case of failures, we have implemented data backup using Google Cloud Platform with data replicated across diverse Google locations. Our application remains resilient against data loss. For system monitoring and alerts, we rely on Firebase's performance monitoring tools to keep track of our application's health and performance. Alerts are set up to notify us of any performance issues in real time, allowing us to address them promptly and maintain a smooth user experience. Looking ahead, the next obvious security step is to further encrypt locally stored private keys using a combination of passphrase and symmetric key encryption. This is a widely used method to store private keys securely on local device. As you can see, the message disappeared in 5 minutes. This message was completely deleted from the database and hence it has no trace to it whatsoever. In conclusion, we have showcased the key features and functionalities of our secure chat application, highlighting its importance in today's digital landscape. From robust user authentication to end-to-end encryption and innovative features like steganography and AI assistance, our chat application prioritizes user privacy and security while also being feature rich and convenient to use.